Hello everyone. So today we will be discussing about a new topic of the chapter soil. So what we are going to learn today, as you all know that we are discussing about the properties of the soil, and every day we are learning a new topic from the soil, isn't it? Now today what we are going to discuss, today we will be discussing about the last topic, okay, among the properties of the soil. That is soil allows water to percolate. Over here what we are going to learn, over here we will be learning an activity to measure the percolation rate of water in soil. Okay, so let's proceed. So we all know that there are several properties of soil. Among them, the first property was soil contains air, that I have already explained. Number 2, soil contains water, the related activity I have already explained. Number 3, soil can absorb water, last day I had explained. And today the final one, that is soil allows water to percolate. Today we will be discussing about this topic. Okay. Now soil, what is a soil? It is a porous solid substance, okay, that is it has got a tiny pores in it. Okay, now what happens when the water is poured over the soil, then some of the water it gets absorbed in the soil, and rest, what happen, rest it passes down the soil via what, via those tiny pores. Okay, so what is percolation of water? The process in which the water passes down slowly through the soil is called percolation of water. That means when you are pouring the water in the soil, at first what happens, the soil it gets absorbed, okay, and the remaining water, when in our last experiment, okay, when I was describing you the experiment which shows the activity to find the percentage of water absorbed by the soil, now over there you had performed one thing, that is you had taken a funnel with filter paper, isn't it? Now when you were putting dry soil into it, and from the measuring cylinder when you were pouring the water onto the soil, then after a certain time, means after absorbing certain amount of water, what happens, the water it starts dripping from the lower end of the funnel. Why it starts dripping from the lower end of the funnel? Because at that time the water it was percolating, because few of the water it was absorbed by the soil as per the absorbing capacity, and rest of the water it was percolating down, that is it was passing down through the soil. Okay, now though water can percolate through all types of soil, it can percolate through clay soil, it can percolate through sandy soil, but the rate of percolation of water, it is different in different types of soil. Okay, for example, the percolation rate of water in sandy soil, it is more, okay, whereas in case of clay soil it is lesser. Okay, but the rate of absorption, it is more in clay soil, whereas it is less in what, in sandy soil. Okay, so the rate of percolation, now rate of percolation of water, what is that? It tells us how fast the water passes down the soil. Okay, now rate of percolation of water and percolation rate of water, it means the same thing. Okay, now if in your exam, if the definition comes that what is percolation of water and what is percolation rate of water, remember these two are different things, the definition will be different. What is percolation of water? The process in which the water passes down slowly through the soil is called what, is called percolation of water. And what is percolation rate of water? The rate of percolation of water in a soil, it is what, it is the volume of water in milliliters which passes down the soil per minute. Once again I am telling you what is percolation rate of water. The percolation rate of water in a soil, it is the volume of water in milliliters which passes down the soil per minute. That is the percolation rate of water, where the time comes, okay, that at what time it is taking, okay, per minute, okay, so that the water it passes down. Okay, so now what we are going to do, we will be doing one activity to measure the percolation rate of water in the soil. For this, what you have to do, you have to take a 20 centimeter long PVC pipe. PVC pipe, all of you have seen that blue colored pipe, okay, blue colored pipe which is used for that in the building, which is used for supplying the water, okay, from the tank to the bathroom, okay, or the sink, Okay, the pipe which is used, that is known as what? That is known as a PVC pipe. So take a long 20 centimeter long PVC pipe having a diameter of 5 centimeter. All of you know what is diameter and what is radius. Okay, radius, if the diameter is 5 centimeter, then radius is it must be 2.5 centimeter. Okay, next what you have to do, you have to dig the soil. Okay, you have to dig the soil to a depth of about 2 centimeter in the ground. Okay, then what you have to do, you have to place one end of that PVC pipe in the dug up ground and hold it vertically. Okay, next what you have to do, you have to take a measuring cylinder. All of you know what is measuring cylinder now. Now fill a measuring cylinder with water. Okay, note down the volume of water that you have taken. It can be 50 ml, it can be 100 ml, it can be 200 ml, it can be 500 ml, whatever you are taking, please note down the volume of water. In the measuring cylinder, you will find the graduations are given. Graduations are given means the measurement, the scale of measurement is given. So from there you can easily note down the volume of water. Okay, next what you have to do, next you pour the water taken in the measuring cylinder in the pipe slowly from the top. Okay, slowly from the top you just pour it. Here you see the diagram. Slowly you just pour the water from the measuring cylinder into the PVC pipe. Okay, next you have to note the time when you are just start pouring the water. Okay, for example, at 12 o'clock you have started what? At 12 o'clock you have started pouring the water. Okay, then what you have to do, after some time all the water poured in the pipe will percolate down through the soil, leaving the pipe empty. Okay, now you have to note the time once again when all the water has percolated down through the soil and the pipe becomes empty. So first when you are counting the time, first when you are noting the time when you are pouring the water from measuring cylinder to the PVC pipe. At that time, suppose you are noting the time, and when you have completed the entire water, pouring of entire water has been completed, then what you have to do, you have to keep an eye inside the PVC pipe. Okay, so that all the water, you have to see whether all the water has entered inside or not. Okay, so at once the PVC pipe, the inside of the PVC pipe, it becomes empty, you have to note that final time also. Okay, suppose it is 12:30. Okay, suppose it is 12:30. So what is the time difference? Time difference is 30 minutes. 12 to 12:30, the time difference is 30 minutes. This is a general measurement I am telling you. Okay, so the difference in the two time reading, it will actually give us the time taken by the water taken in the measuring cylinder to percolate into the soil. Okay, that was actually the time taken. Now how will you find out the rate of percolation of water? It will be done by using a formula. Okay, what is that formula? The percolation rate of water in the soil, it can be calculated by volume of water percolated in the soil. Volume of water percolated in the soil, that means the amount of water which you had taken in the measuring cylinder, that is the volume. Okay, suppose 50 ml. Okay, divided by time taken for percolation, that is the time difference. Suppose there I said you 30. Okay, so what you have to do, the volume of water percolated in the soil divided by the time taken for percolation. Okay, so this will give you what? This will give you percolation rate of water in soil. Okay, and what is the unit through which this percolation rate of water in soil is expressed? Milliliter per minute. Okay, milliliter per minute, because in ml only you are taking, in milliliter only you are taking the volume of water. Okay, so that is ml, volume of water, that is expressed in ml, and time taken, basically it is expressed in minute. Okay, so milliliter per minute, that will be what? That will be the unit for the rate of percolation of water in soil. Okay, so based on this formula, okay, the numericals can be given. Okay, so numericals in your exam also, the numericals can come. Okay, based on this formula. Okay, now suppose if anyone say that the percolation rate of water in the soil is 5 milliliter per minute. Okay, 5 milliliter per minute. So what does it mean? It means that the rate of water in this soil it is 5 milliliter per minute. That means 5 milliliter of water passes down through this soil in every 1 minute. Okay, 5 milliliter of water passes down this soil in every 1 minute. Now some additional information I want to give you. As I said you that percolation rate of water, it is highest in which type of soil? Sandy soil. Why? Because it is quite loose. Okay, whereas as I said you that clay soil, since it is very compact and tightly packed, so the percolation rate of water, it is lowest in clay soil. Okay, but the rate of absorption that is highest in clay soil, whereas in case of sandy soil the rate of absorption is very, very low. Okay, because the water generally in the sandy soil, it percolates down. Okay, now it has been found that 8 to 10 days after the rain, the level of water in a well rises, isn't it? Now the sandy soil having the highest percolation rate, it allows the rainwater to reach a well faster in a greater amount. Okay, now the clay soil, since it has a lowest percolation rate, okay, so it retains the highest amount of water in it, okay, rather than it allows them to percolate. Okay, so this is all about your activity to explain water, that soil allows water to percolate and to measure the percolation rate of water. So next day we will be discussing about soil erosion. The properties of soil is finished. 2 more topic is left. Next day we will be discussing about soil erosion. Thank you everyone.